For any project or relationship to succeed, you need great communication. That means you need to be able to convey a message or instruction to someone else. They need to be able to understand that instruction and respond in a way that you expect. An architect, for an example, takes on board a client's instructions and they convey their design intent to an engineer. And an engineer needs to convey the details to a contractor. And a contractor needs to deliver a project that satisfies the client. The chances of that happening successfully with a single handoff of information must be infinitely small, if not impossible. The chances of success are dramatically improved if there's a constant flow of two-way communication. And the earlier the involvement of all parties, the better, as each will bring a unique perspective and set of experiences. People can build better things together. People can build better things when they have a common goal, a shared vision of project success. Now, you don't necessarily need to have a contract like integrated project delivery to achieve this goal, but you do need a project team that are engaged and focused on the bigger prize, whether that's thinking about repeat business or a better reputation or better project outcomes. My name's Paul Walker. I'm a senior product manager leading the Coordinate group for Autodesk Construction Solutions. Having spent the last 20 years working in BIM for construction, covering products from Navisworks and BIM 360 Glue to layout and model coordination, I'm driven by a desire to simplify processes and increase collaboration through connected data and workflows, and fusing that with some of the latest technologies. Now, the solutions we're providing are helping many companies to thrive, helping to increase project efficiencies and project outcomes. During this session, I'm going to share some of the ways in which they've achieved this and how you can too. Construction management is a highly complex and multidimensional undertaking with significant risk in each phase of the project lifecycle. And to make things even harder, phases aren't sequential, with accelerated schedules driving to break ground as soon as possible. Timely handoffs are vital to successful projects. And if that data isn't coordinated, you run the risk of costly rework and project delays. Communication breakdowns occur across teams and can show up in different ways. Architects and engineers need to contest with changing owner priorities, design change control, and the ripple effect of each team referencing each other's content, and managing a single source of truth. BIM managers and project leads, they must balance the pressures of construction schedules, ensuring they have people working to deliver the right information at the right time. That project teams are accountable for their deliverables, and overcoming the inefficiencies of disparate data management solutions. MEP engineers and specialty trades, they need to deal with rigid design requirements or working with out-of-date information, unclear or unaware of project changes. This fragmentation of data and workflows has a huge and direct impact on the project outcomes across all levels of the organization. Teams are disconnected and working from outdated information due to multiple apps or even the complete lack of digital adoption, leading to lots of wasted time and security issues due to unnecessary people on the job site. At the project level, the disconnection between the office and the field accounts for massive avoidable rework, impacting project cost, quality, delivery time, and profitability. There's a considerable impact at the business level as well. Unused and lost project data is reducing potential opportunities such as operations and maintenance or portfolio visibility. The construction industry is becoming more connected, from people to data, and technology plays a key role within this opportunity. If we look at the design coordination process, Originally, that took the 2D sheet deliverables from different trades and disciplines and overlaid them on a lightbox, manually looking for constructability problems, which were communicated through physical markups, reports, and eventually spreadsheets. Then a certain level of digitization happened, and those sheets could be digitally overlaid in desktop applications. Then later, 3D models themselves could be developed and analyzed to identify problems. But again, data was predominantly locked on the desktop, and outward communication remained difficult. Now, more or less, this is where many of you will find yourselves now. You've started integrating and sharing information through emails, FTP sites, and other storage and transfer apps, but often still working within silos. Different sets of tools being used in different phases. Multiple solutions popping up to solve similar problems, and data spread across multiple applications, which is difficult to use for any insights. So how do you start to break down these silos? Now, you can't simply say that everyone must use a single tool set, as everyone's needs are different, depending on their role and project phase. This is why we have taken the approach of an underlying platform to support these multidisciplinary project teams for whichever client they're working in, be that a desktop authoring app like Revit, Advanced Steel, or Civil 3D, a web client such as Docs, design collaboration, model coordination, cost management, or Quantify, or mobile site tools like Build. The new possible lies on connected construction. Permissioned common data available to everyone that needs access. See the impact of changes being made by other teams. Automated clash detection for self-checking. Empowering design and trade teams to improve the quality of their models. Connection and flow of data to the field. Assign, track, and review issues from multiple apps. See the history throughout the project. Ask relevant people for more information. Provide integrations and connections with third-party tools. All of these things together give the platform its strength. This is what better communication looks like. Connected issues provide a common language or a vehicle for communication across different apps and users. A common data environment connects teams across tools and phases. Pre-construction, project management, and design tools all have access to the same issues layer. Issue status and responsibility are highly visible across the project teams. Issue details and context persist from design to the build phase. And those design tools, often required to resolve issues, store their data in the CDE. Issue creation is available in the various apps used by team members whose role it is to look for potential problems, aiming to capture these before they become real problems. Issues are then available to all those users and more within their appropriate app environment, where they can review and edit details, add comments and questions, and ultimately assign for resolution. Issue resolution may take many forms. It may simply be a response to a general question or a housekeeping task on site, itself being identified by the issue type. Or it may require a design modification, where the issue needs to communicate appropriate context to a designer or engineer. With all of this data being gathered centrally across all phases, it starts to build up a picture of the project, what's happening where, who's involved, whether parties are responding to and addressing the issues being captured. When you can see who an issue is assigned to and know that they're working to resolve it, or you send a question and get a response, it helps to build those relationships and trust. It fosters collaboration and it encourages working together to solve problems. Enough of the theory. Let me show you how all of this works. Autodesk Docs provides the platform and common data environment for managing project data. Revit Cloud work sharing, collaboration for Civil 3D, collaboration for Plant 3D, and Advanced Steel can all natively store data in the Docs CDE. Design collaboration enables control sharing between teams, where you can review packages of 2D and 3D content. Automated change analysis can advise on newly added, removed, or modified content between versions. And model coordination enables multi-format, multi-discipline aggregation with support for Revit, DWG, IFC, NWC, and VUE formats. And automated clash detection, think of this a bit like spell check, can assist teams understand conflicts within their own models. The automated clash detection and control sharing capabilities of BIM Collaborate gave WSP Canada the opportunity to try a new clash avoidance workflow. Working with Bird Construction and Autodesk, they developed a workflow that saw all designers spend around 15 minutes each morning reviewing the clashes with the area of the project that they were each working, and directly fixing these in Revit. This was ahead of sharing their latest models with other teams at the end of each day. This iterative approach to constant model quality improvement is conservatively saving a 20 to 30% reduction in BIM managers' time. And that's not to mention the massive suppression in noise observed by other teams and reduction in issues going forwards to coordination meetings. This workflow has been implemented on 10 to 15 projects so far. Please refer to the class handout where I'll go into further details. There are two primary workflows in model coordination: constructability review and clash management. You can aggregate and review any combination of supported models and save these as a composite view, either to be used by all members or something specific for yourself. You can then navigate through the models, accessing object properties and so on, looking to see whether the combined design works practically, whether it can be built or maintained, depending on your role in the project and the perspective that you bring. You can capture any observed problems as an issue, assign it to someone on the project, set a due date and other attributes, and add comments and questions. Notifications will be sent to appropriate project members where they can access the details. A screenshot for extra context, and also be able to respond. Identified clashes can be assigned as an issue or closed as not an issue, where no remodeling is required, for example. Active clashes are displayed in a matrix based on the authored model files and published 3D views. These can be filtered to focus on a specific area, either by naming convention or a predefined composite view. Further grouping and filtering tools are available to refine how you wish to review the data, including tolerance, where you may want to focus on bigger clashes at the earlier design stages and tighten during trade coordination. Clashes by default are grouped by object, with you controlling the primary model. This means all clashes with any HVAC object, for example, can be treated as a single clash group. Alternatively, you can choose other grouping methods, including using type name or system name or layer name for DWG files. The grouping options will adjust based on the primary model file type. The effect is to group related clashes so that they can be dealt with as a single issue. With a problem clash group identified, you can create an issue, specifying the object most likely to be modified to resolve the problem. Additional contextual data is automatically stored along with the issue, and a title and description are added, but you can edit these as required. You can assign the issue to a relevant project member, job role, or company. Location and other attributes such as due date can also be set, which benefit future search and filtering when managing issue lists. A screenshot of the clash is also captured automatically based on the view configuration when the issue is created. Meetings are integrated into model coordination, where you can define and manage a coordination meetings, schedule and invite participants, and specify an agenda of topics to discuss. This can include reference to specific items, including issues. The meeting form can be further used for meeting minutes, capturing attendees and notes. Issues can be updated with agreed commitments, including who will take responsibility and with due dates and so on. Autodesk Navisworks can open and append content from model coordination, enabling additional user-defined analysis from clash detection to 4D simulation in its familiar interface for many power users. All Navisworks tools can be used, including creating search sets and then using these to define specific clash tests with specific rules. These clash results can also be grouped and marked up. Navisworks is also integrated with the Common Issues service, enabling review of issues created elsewhere in the system, or you can directly create issues here, with access to the same data fields, assignees, and a screenshot is also captured, including any markup. Issues may be associated with a version of a file in another folder, due to control sharing workflows, for example. The issues integration within Revit enables issues to be loaded from multiple folders to account for such workflows. Issues can take you directly to the 3D view in which the issue was created and set the camera view. And all issue details are accessible, including screenshots for context. With the associated object selected, you're ready to resolve the problem in whichever Revit view is most appropriate. As Revit works at a connected system level like this, moving a single object will automatically adjust the relevant system elements too. After making changes to the model, you can then change the status of the issue and add comments and reassign the issue if necessary. Autodesk Build provides web and mobile apps for capturing issues during the construction phase, including quality and safety issues, for example. Build includes a full issue log with access to issue details, screenshots, and photo attachments. Build also provides project management tools for assets and RFIs. And during pre-construction, if an issue cannot be resolved amongst the project team, it may be necessary to escalate an issue to an RFI. This capability is directly integrated into the issue experience, where you can either reference an existing RFI or create a new one. RFIs can be configured for specific permissions and workflows, including additional reviewers. Each RFI will have a single person identified at any given stage to be clear who has the ball in court. Once your question and suggested response are added, the RFI will be linked to the issue and its predefined workflow kicked off. Insight provides dashboard-style presentations of project-level data, analytics, and predictive insights. These can help to understand what's going on in a project, looking for trends or patterns, and trying to identify any gaps or problems. Dashboard cards can include issue status and assignees, design packages, RFIs, and so on. There are predefined dashboards, or you can create your own with access to the data that you're interested in. This also includes a vast number of partner cards, such as Microsoft Power BI, where you could configure further analysis based on your project data extracted through our data connector, which makes it even easier to get your data out. Issue reports can also be scheduled to run and sent out to specific project members, keeping everyone informed of open issues and commitments. What I've been discussing today isn't hypothetical. Similar to the workflow of WSP Canada that I mentioned earlier, let's hear this in the words of one of our customers, Lee Ramsey.
My name's Lee Ramsey and I'm the Design Management and Digital Construction Director at Morgan Sindall. Autodesk Construction Cloud has been helping us improve the design management processes and model coordination. We've seen improvements in productivity and outcomes, helping our teams handle further capacity. These benefits have transpired in many different ways. We've seen the design teams take on more ownership of the information that's being produced. Each member automatically clash detects the work before issue. It's a bit like spell check. Design meetings have taken less time. We've seen a lot less comments when reviewing 2D outputs and addressed the issues at source in the 3D model. For example, design team meetings have been reduced by 67%. The synchronization of models and uploading and downloading models has been reduced by 78%. What has taken hours is now taking minutes. All parties are seeing the design as the design develops, almost in real time. This has reduced a board of design work. The model coordination comparison tool has been a significant benefit, and design members have seen a 50% time saving in the identification change, as everything is visible. We've seen the time to review information reduce. For example, we've seen a 20% reduction in our pre-construction phase. We've seen a 20% improvement in time to upload models to coordinate with other disciplines. The identification of change has significantly improved. We've seen a 62% saving in time to do this activity. People are self-managing and identifying their own issues and resolving them and controlling their own work. The traditional clash detection process, which would take 3 weeks, is now taking minutes through the use of Autodesk Construction Cloud.
The Autodesk Construction Cloud provides the platform and connected issues to bring people, software, and phases together. We're enabling design teams to continuously collaborate to avoid clashes as much as possible. We're facilitating multidisciplinary communications with greater accountability and native issue resolution. We're enabling faster time to site and reducing costly rework, whilst tracking across phases and providing downstream context. This all comes together as better collaboration, better communication, and better project outcomes. Please go to the Autodesk University site for this session, where you'll find the class handout and links to learn more about the products and workflows mentioned during this session. Thanks for watching.